In today's video, we are going to look at how to solve this type of simultaneous equations, which involves the loss of indices. Now, we know previously that when we talk of simultaneous equations, we can either use a substitution, or we can use elimination, or graphing the two equations in order for us to solve the two equations. But in this case, we have to use the loss of indices to actually solve them, so we can come up with either a quadratic equation, and then we can now maybe use the quadratic formula, or maybe completing square, or any other method. Now, without wasting time, let's get into it. Now here, what we are going to do here, we are given that 3 to the power x times 243 to the power equals to 1. Now, what we can see here, we have this number here with a base of 3. It means we have to write 243 as a power, making sure that the base is 3. Now that will become 3 to the power x times, if we write that as a power, then we're going to have 3 to the power 5. And then in brackets we can put y equals to, we should also write 1 as a power. The base should be 3. Then we are going to have 3 to the power 0. We know anything to the power 0 is equal to 1. The next equation we are going to write, with this equation, if you can check very well, it will be easy if we can write this 8 and 16 as powers, making sure that the base is 2. Now 8 as a power, we are going to have 2 to the power 3, and then we can put the x in brackets, and then we will divide 2 to the power y minus 12 equals to 1 over 16. We can write 2 to the power 4, and then brackets 1 over y. This is the first step to do. Once we are done with that, then we can now work on the exponents. Let me use a different color here. Now what I can see here is that here we are multiplying 3 to the power x times 3 to the power y, 3 to the power 5 y. So when we are multiplying, we add the exponents. So we write only 3 to the, and then we add the exponents, which is x plus, this is 5y. Then we just write 5y equals to 3 to the power 0. While the second one, we are going to have, we only write the same base, which is 2. But since we are dividing here, therefore the exponents we subtract. This is 3y minus, not y, 3x, sorry, it's 3x minus, we have to put brackets because this negative will affect all the numbers inside the brackets. Then we have y minus 12 equals to, now this we can rewrite it 1 over 2. We distribute this 4, what we have inside there, then we are going to have 4 over y. But this is the same as writing 2 to the power negative 4 over y. So I will now write that instead of writing that fraction. So I can now write 2 to the power negative 4 over y. Now we know that when we have two equations and the bases are the same, it means the exponents are equal. The bases are equal, therefore the exponent should also be equal. So we can now write x, we leave out the bases, x plus 5y equals to 0. Maybe instead of us using equation 1 then 2, okay, it's fine, let's use this one now. Let's put equation 3, and then here instead of writing 2 we now only write 3x minus negative 1 times y. We get that negative y, negative 1 times negative y, negative 12, we get positive 12 equals to, we don't need to write that, we only write the exponent, which is negative 4 over y, and this becomes our equation 4. Now here we have a linear equation. The second one, equation number 4, is a quadratic equation. To see that, if we can multiply throughout by y, the same this side, we also multiply throughout by y, then what we are going to have, y times 3x, we are going to have 3xy minus, I'm leaving out that equation first, I want to work out the second equation, which is equation 4. Y times negative y, we are going to get negative y square, and then plus 12y equals to negative 4, since this y and that y will cancel. I just simplified equation 4 here. I did not change anything, I only simplified to write this as a quadratic. Maybe we can rewrite this to start with the square term, negative y square plus 12y plus 3xy equals to minus 4. Now what we can do here, let us use substitution. We can use substitution method. This equation, we can rewrite it as, let's make x the subject of the formula. Then we're going to have x equals to minus 5y. This is a very important equation. I'm putting a star there. So where we have x here, we substitute in negative 5y. Then we can now write this as y squared plus 12y plus 3, and then x equals to minus 4, where I leave open spaces for the value of x, which is negative 5y. Then I can now write negative y squared plus 12y. This should be minus now. This should be minus. Wait. Yeah, this should be minus, not positive. Minus 15y squared equal to minus 4. Now what we can do here, since we have like terms, this and that, they are all negative, therefore we just add them, then we get negative 16y squared plus 12y. We can now bring this negative 4 to this side of the equal sign to become positive 4, and then we equate to 0, and that is the quadratic equation that we wanted to get. Now here you can either use it's easy if we can use the quadratic formula. So, but before I use the quadratic formula, let me try to simplify it by dividing throughout by 4. Then I have negative 4y squared plus 3y plus 1 equals to 0. If you want, you can stop here and then use the quadratic formula to simplify, not simplify but solve for y. Let me now use this. Since I'm solving for y, then I write y equals to negative b plus minus square root of b square minus 4ac everything over 2a. My b value is positive 3, therefore I have negative 3 plus minus 3 to the power 2 minus 4 minus 4 positive 1 here, 2 times negative 4. Then what I have here is negative 3. Let me use positive first. Then I can now work out the square root. Not the square root, but yeah, actually the square root, which is the discriminant there. Minus 4, negative 4. Then I'm getting positive 5. Over, this will give me negative 8. Or y equals to negative 3. I used positive here. Let me now use minus 5 over negative 8. This 5 is still the same. It's actually this number that I got under the square root there, which is the discriminant. Now here I can now say negative 3 plus 5 is positive 2. You divide by negative 8, we get negative 1 over 4. Or y equals to negative 8 over negative 8 is positive 1. These are the y values. But since we are solving, we need to have two coordinates. Since you are solving two equations from the beginning here, we have x and then y. So now we have the values of y. We also want the values of x. Now the equation that we are going to use is this equation here, where we made x the subject of the formula. Let me rewrite that equation here. X equals to minus 5y. Then for me to get the x values, negative 5, let me first use here negative 1/4. Then I'm getting x equals to positive 5 over 4. That is when, this is when y equals to negative 1/4. And the other x value, they rewrite that formula, negative 5 when y equals to 1, then x equals to minus 5. Now the final answer should be indicated like this. Here is x, y, x, y. So the first x value, which is 5 over 4, that is when y equals to negative 1 over 4. While the second value of x is negative 5 when y is positive 1. So it means these are the solutions to the two equations. But how do we make sure? Let's quickly check in the original equation to substitute in the values. Let me rewrite the values this side and then we can substitute in. We found 5 over 4 and then minus 1 over 4 and then minus 5 and then y. This is x, that is y. This is x, that is y. Before we come there, I forgot something here. It is always it's always advisable to leave your answer as fractions instead of giving decimal numbers. This is an improper fraction. You don't need to write it in that form as a mixed number. If you leave it like that, it's 100% fine. Now let's check if our answers are correct. Let us, in the place of x and y, let us put in these two values first and see if we are getting 1. 3 to the power 5 over 4 times 2, 4, 3 to the power, the y value is negative 1 over 4 equals, let's see if we are getting 1 equals to 1. Indeed, we are getting 1, which we have there. For that equation, it means these two values, x and y, they are correct. Let us also use the same values in the second equation. We have 8 to the power x. Let's put in 5 over 4. Here we are dividing 2 to the power. In the place of y, let us put in negative 1 over 4 minus 12. Let us see. Okay, in this case now, since this side we are not given a number, let's see which number we're getting this side. Let us write the number that we are getting this side. Let me use blue. The number that we are getting this side, let us write it down. Here we are getting 6, 5, 5, 3, 6. Let's see if we are getting the same number this side when we substitute negative 1 over 4 in the place of y here. We have 1 over 16 to the power 1 over negative 4. Yeah, wait, this should be negative 1 over 4. Okay, this side we are getting a 2. Let me see. It's 16 to the power which is 1 over 16 to the power positive that. Oh, no, I did not punch it correctly. Let me redo it. It is 1 over 16 to the power 1 over negative 1 over again 4. This is how it's supposed to be. Yes, you are getting the same answer, which is 6, 5, 5, 3, 6. So it means these two are correct. You can also go ahead. Let's try these two in the first equation, which is very easy. We have 3 to the power negative 5 times 2, 4, 3 to the power 1. We should get 1. So it means these two are also correct. That is basically how you can actually solve simultaneous equations of this form. If you are new to this channel, please do subscribe for more videos, and I appreciate for watching these videos. You can also tell a friend to like and comment, and if you want me to solve a specific question for you, you are more than welcome to actually drop it in the comments.